It's just a way for you to get familiar with some of this conditional probability stuff with Python, with Git, and all of these kind of things. So it comes out at the end of next week. There'll be a lab at the end of next week, and of course a lab at the end of this week as well, which is, so this is the only lab which is in class, right? All the other labs are in sections. But you will get a notebook, and there will be a video which will come out to you on Fridays. So next Friday there'll be another video, there'll be another notebook. Now the week after that, that is the week after the next week, is a week of sections. And that week of sections will cover a lot of the material that's kind of important for the homework. And then after that you have one more week, and then you got to submit your homework. So that's essentially what this is sort of showing, that the homework is that last column there, and you have those 2 weeks to do the homework. The section which is kind of, the sections which are relevant to the homework are the previous 2 sections, i.e. today, so more like next week, all of next week, and then all of the week after. And then the lectures that are relevant are the ones which will be only in next week. So anything that's on homework 1 will not be after what's done in next week on lectures. So the week after's lectures will not feature on homework 1. So in that sense, we're not sort of like, we're trying to keep this a little bit spread out. It does mean that you're actually at any given point when you're working on a homework, you're doing stuff which you learned about 2 weeks back, and you're already learning new stuff. So it's kind of a little bit more onerous as far as you're concerned, because you have 2 streams of knowledge that are coming in at the same time. But it's a little bit easier on the homeworks in that perspective, that you're not sort of scrambling to get the stuff that you need otherwise. So I just wanted to push that up. So sections run the whole week. This is the only time we'll have lab in class. The equivalent of this will happen in your sections next week and the week after, and so on and so forth. We wanted to do this today because Git is not an easy piece of software, but it's a very powerful piece of software, and almost any industry job that you now go for, you need to be actually fairly proficient in Git. So that's part of the idea here. And that's generally part of the philosophy of this course. So this course has some really theoretical stuff that will be done in the lectures, but the labs and the sections are really hands-on, really practical, nitty-gritty, dirty Python stuff. No question is forbidden, right? It's actually getting the stuff done. And from that perspective, we're trying to do this course in a way which combines some of the more theoretical stuff with a lot of stuff that's actually very much sort of practically oriented. So I'll just give you an example from the kind of homeworks you're going to have. The first homework's actually going to have you look at music ratings and how to sort of perhaps make a predictive model from, we won't actually make a predictive model, but see what it takes to make a predictive model from these music ratings. And it'll require scraping Billboard and Wikipedia. The second homework goes over to elections, and you'll be actually predicting, well, post-predicting, because they're already over, the Senate elections in 2014. You'll be making mistakes. You'll be seeing why not only you made mistakes, but everybody else made mistakes, including Nate Silver, got it wrong. Everybody got it wrong. And we'll be seeing how you can maybe not get it as wrong. That's the second homework. The third homework is going to put you in the slightly grubby spot of being a direct marketer who sends out these junk mailings, and figuring out for your boss who to send junk mailings to using machine learning. And that has not, from going back to this practical aspect of things, that just doesn't have, not only has machine learning in it, but also has like practical consequences of if I make a classifier which predicts to this level how much profit I can make, and how you can use profit, for example, as a metric to figure out what to do. So it's extremely practical. Homework 4, you're going to actually take the Yelp data set, and you're going to make recommendations. And essentially, you're going to mini follow what the folks who did the Netflix prize followed. You're going to start by making a nearest neighbor recommendation. You're going to do a regularized least squares kind of recommendation, and then you're going to combine the two as in an ensemble method. And then in homework 5, you're going to do a lot of text analysis. We haven't quite figured which data set as yet. It might either be also from Yelp or from Twitter, or maybe we'll even combine those. And you'll actually combine naive Bayes type supervised learning algorithms where you try and figure out, I know some emails are spam. Let me predict the rest of them. But here in more detail. I know that these particular reviews are about the decor in a restaurant, and those particular reviews are about the quality of the food. So how do I figure out these various things in both supervised and unsupervised fashions? And then how do I actually bring in statistical strength in the case where I don't have too much reviews? So that's your 5 homeworks. They're all very practical. All of them, if you were to like join a startup at the end of this year, you would probably be able to put those skills right to use. That's kind of the idea, that if you join a startup at the end of this year, you should be able to put these skills to use immediately. And that's also why in the last week we have lectures on experimental design for A/B testing and so on and so forth, so that if you have to do an A/B testing on your startup's website or something of that sort, you're equipped right off the bat. So in other words, what I'm trying to say is that if you do the practical parts of this course really well, you're probably better off than most data scientists who take one course. The flip side of this is that there is a lot of work in this course. And you should know that, and it'll be dishonest to say anything otherwise. 2 years back, when I also TF'd this course, we had a double hump distribution of the amount of time people took to do the homeworks. So over a period of 2 weeks, the first hump had a maximum at about 14 or 15 hours, with a plus or minus about 4 or 5 hours on each side. So there were people who finished it within 10, and there were people who took more than 20. But then there was a second hump of people who were at about 30 hours for 2 weeks. And in general, these were people who didn't have both, who didn't know both statistics and programming. But there were a lot of people who did it, and there were a lot of people who could turn out to be amongst our best students. But they had to work 30 hours a week. So that's sort of like the kind of distribution that we had. But the majority of the mass of that distribution was in that 15 hours distribution. So that's the kind of work you should expect on a per homework basis. Okay, so let me start this back up. Okay, so now we'll start the sort of like lab proper, and this is the part that's also being recorded for those who couldn't make it here. What I'd like to do is essentially start off with the Python parts of things, and move on then to sort of the Git part of things. So the Python part of things that we want to do are actually in the lab GitHub, which you should have been able to access. Has everybody been able to get to this web page? If not, you should get to this web page. It's on GitHub. You don't need to be logged on or anything. It's kind of, well, you need to be logged on to clone it, but it's publicly available. And inside of this, there is a lab which is called lab1 Python pandas.ipynb. I should actually increase the size of this. It's probably too small. Yeah. So this is the page you're going at. Doesn't matter if you're not able to clone stuff. Okay. There are 3 ways you can follow. I mean, if you don't have the Git stuff working, don't worry about it. We'll have that working all within the next week. But what I would like you to do right now is one of these 3 possibilities. One possibility is that you don't actually want to work through the Python right now, in which case you just click on the lab. And if you click on the lab, you'll be able to see the lab in the interface, in the website interface. You can't run anything, but you can see what's going on. So that's one option you have. Okay? The second option you have, and you ought to use this option only if you haven't installed Python, because if you have everybody in this class actually clicking on this red thing out here, that site's gonna, I think, die. So it's only if you haven't installed Python. If you click on this, you'll get. Let's see, did I do it here? No. So let me do it. I'll click on this. And if I click on this, it takes me, if you look up there in the upper left corner, I don't know, how visible are things? That's kind of small, isn't it? At the top. But you don't need to read it. Let it just come up. It'll take a bit of time, and it will actually populate an IPython notebook environment. What it actually does is that it spins up a new machine for you somewhere online using a particular technology which some of you might be familiar with called Docker. And it's running on a Linux virtual machine, and it's actually running a virtual kind of like jail, if you like, on that Linux virtual machine using Docker. And it actually it's taking a bit of time. We may have already saturated it. No, here it is. It's coming. Yeah, so what this does is that it'll actually put all of the files which are inside this repository in an IPython notebook folder, and then you'll just be able to click on this particular lab that we're talking about and run it. The other option, of course, is to download this. So while this is going on, let me just show you the other option, which is you go to try.jupyter.org. And that's the Jupyter. That's the new name for the IPython notebook, by the way. It's Jupyter. And the reason it's Jupyter is Julia, Python, and I have no clue what the ER part is. I guess that's just for Jupyter. But so over there, it gives you this thing, and you can upload. And if you have a local clone of that, or if you've downloaded it previously locally, you can upload from here. So for example, I can go to here, and projects, and CS109, lab1, because I've cloned it down here, and I can just upload the Python pandas. You have to then upload the data files as well, which is a bit of a problem as far as that is concerned. But it's not, is this an older version? No, so that's the original Python pandas. So if you do that, it's going to upload it. Meanwhile, let me just see if that one has still coming up. It's taking its own sweet time. So I have this upload, and then this will upload. So that's your other option here, lab1 Python pandas. The problem is in uploading data, and this particular one does need some data, and I can show you how to change that as well. So this is running it on try.jupyter.org. If you have your local machine set up, then you should run it on your local machine. So how many people have actually loaded this file onto their local Anaconda IPython notebooks? And how many people haven't or don't know how to do it? Okay, so this means that I should actually explain that. So let's do that. So give me a second here, and I will do that. I'm going to shut down the IPython I'm running right now, so everything is like clean room. So now this depends on how many of you have cloned down. Let me ask the question before that. How many of you have cloned down the repository to your local machines? How many of you don't know how to clone it to your local machines? Okay, so there's a lot of people who don't know cloning at this particular moment. Okay, so let's start from the very basics here. In fact, let's not even worry about cloning it at this particular moment. I'm just going to go here, CS109, and we'll do it in a slightly different way right now, and we'll do the GitHub part in the second part. So here, there's a little thing over here which says download zip. Do you see that? At the bottom right, it says download zip. Click on that from this particular URL. This URL is github.com. The way I go to this usually, by the way, just so you know, is github.com. I type github.com/CS109. Just that. And if you type just that, I'll give you the set of repositories, and there you go and look for 2015 Lab 1. There's 2015 Lab 1 over there. And you click on 2015 Lab 1, and it's going to take you back to this page. Okay, so that's how you get there. You just need to remember github.com/CS109, and you'll be able to get there. Okay, then you click on download zip. So boom, it's going to download it into my downloads folder. So I'm going to go to my Finder, and I'm going to look at my downloads folder again. Does anybody know how to make this look bigger? View. Oh boy, okay. Well, I'm going to let you guys deal with that part. So I'm going to click on date modified. Sorry, I'm in documents, I'm not in downloads. And so it apparently completely sort of like opened it up for me by itself, at least on the Mac. On Windows, you might have to do an unzip or double click on it or whatever, depending on your operating system. And you can just go in there and you can see all the files. Now, one of the most important things in this course that you will learn, which nobody will teach you, and not even me, is how to use the terminal. You must learn how to use the terminal if you want to be a good data scientist, because Python's not the only thing. You can use R scripts on the terminal. You can use a lot of terminal utilities like grep, sed, awk, and all of these things to actually do a lot of good data science. Awk in particular is incredibly strong. I remember when I was doing my graduate school thesis and Python didn't have all of these nice bells and whistles. I think I did most of my stuff with awk. And it's really powerful. You can do a lot of mathematics right on the command line. It's harder, obviously, but there's always this trade-off between ease of use and what you can do with it. So you have to figure where you want to be on that trade-off. So here's what I'm going to do. I'm going to start a terminal. And the way you start a terminal is by going to your applications folder. On Windows, if you install Git already, you should have Git bash, and you should use Git bash. But you can also use the standard Windows terminal, which is command. I think it's command.exe, or somebody should correct me, because I really don't know much about Windows, and I might be spouting nonsense. Okay, so let's go and get a terminal. So I'm going to go to my applications folder. Here I can just go to my launchpad over here. And over here, there should be a utilities folder somewhere. I don't know if actually this launchpad does it. Yeah, I'm not 100% sure how the launchpad works. There should be a utility, something like this. Yeah, you could just do command space, which, thank you for saying that. Command space will bring up Spotlight, and just type terminal in it, and it'll bring up a terminal. That's actually a much better way of doing it. Just hit command space. By the way, you can type any application into Spotlight, and it'll bring it up. It's much faster than actually going on your file manager. On Windows, it's similar. When you go to your start menu, there's that little search thing. You can just type any application, and it'll bring it up. So here, I'll bring up the terminal, which, of course, is incredibly small. So let's make that incredibly big. OK. So now in the terminal, I'm going to go into my downloads folder. So for that, you do cd change directory, downloads. And I can do ls, which is just a short form for list, and it'll list all the files I have here. And it'll tell me all the files I have here. So then I can go into this particular thing I saw in the Finder, which was 2015 lab1 master. And now I am in the terminal in this folder. On Windows, you'll have to do something similar. Presumably, it also got into your downloads folder on Windows. CD works on Windows as well. ls does not work unless you're using git bash. ls will work perfectly well. You might have to do dir, dir. That'll tell you the contents of your folder. And then you go again cd into 2015 lab1 master. And if I do an ls, it'll show you all of these things. Now, you should just be able to type IPython notebook in here. And it will bring you to the notebook interface pre-populated with this folder. End of story. You don't have to do anything else. So for me, it says not found. And the reason for me it says not found is because I store this in an unfamiliar place, which is in Anaconda bin. For you, this may not be an issue if you just use the defaults. If you were like me and did not accept the defaults and told it to install somewhere else, you might have this problem as well. So you might need the full path to it. And if you run this, this will open up a little browser window, actually not so little browser window, with all of these files for you. So who's not been able to get to this point? Okay, so there's a second way of doing this, which I'm going to show you now. Okay, so I'm going to kill this on mine because I want to have only one of these running. On your desktop, somewhere on your desktop, when you install Anaconda, there might be this launcher icon, basically. Click on that launcher icon. And if you click on that launcher icon, it will give you this kind of loading apps list thing in there. And you see this IPython notebook is one of the apps. You may not have the same apps that I have because I've installed some other things, but you should have at least some of these. So you'll see the IPython notebook, and there'll be update launch. Don't worry about updating right now, but just hit the launch button. And it's going to launch it. And it's going to launch it basically most likely in your home folder. Right? I mean, on Windows it might vary again. But on the Mac, it launches inside your home folder. And then I can just use this as a file manager. So I'm going to go into my downloads. I'm going to go into my 2015 Lab 1 master. And boom, I am where I was before. So what are the steps I did? I clicked on that little green snaky looking icon on my desktop which said launcher. Once I clicked on that, I had an interface which looked like this. I clicked on the IPython notebook, the launch icon, the blue launch icon over there. It launched me in my home folder like this. Since we had downloaded the zip file to downloads, I double clicked, went to downloads. If you already unzipped your file, double click it, and it takes you inside the folder. Yes? This is totally equivalent to typing IPython notebook. In fact, what it does behind the scenes is that it brings up a terminal, types IPython notebook in your home folder, and just does that for you. Okay, so it's your choice how you wanna start this up. This is a perfectly reasonable file manager, so you can always use this. Okay, so now. And if you don't have this, I wonder if the try.jupyter.org business, you can use the try.jupyter.org business, or you can just look at it. This thing doesn't seem to be particularly loading for me at this moment. We may have already killed it. Yeah, so that may not work. But if you go and do it, if you go and do it away from this lab on your own, it probably will, because there are not too many people on it as yet. Not too many people know about it. You guys may be the largest single group of people who knows about this application on Earth at this particular moment, which is probably not a good idea on my part, but trial by fire. Okay. Okay, so we're here. So what I want you to do is load up the Lab 1 Python Pandas. You'll see that in all of these Git repositories we create, there is a Lab 1 Python Pandas or whatever, homework 0 or something, and there's a homework 0 _ original. Do not touch the _ original file. The reason we have the _ original file is because we're human, we make mistakes. You will find that once the homeworks come out to you that there are likely to be some mistakes or the other, and we fix them quite early in the cycle, very often with your help, actually. Students who attack the problem sets right away say, that's bull, whatever. That's wrong. You've done this wrong. Here's the correction. They submit the pull request, and we fix it, and then we send it out to you. So do not touch the _ original files. Also, if anything happens and you clobber your own work in the other file, you'll be able to just copy it from the original file, right? So by mistake, if I just removed lab1 _ Python Pandas because I did something weird, I can just copy lab1 _ Python Pandas _ original to lab1 Python Pandas. Now, there were some questions on Piazza yesterday. Do the labs need to be submitted? No, they don't at all. The reason we want you to do the labs using the Git interface, though, you don't have to. You could do just do the zip right now that we're doing right now. But we want you to, in general, do it using the Git interface because Once you start working on the labs, you'll have comments that I didn't think of putting out there because I have the benefit of programming Python for 10 years. So there are some things which are blindingly obvious to me, which are not going to be blindingly obvious to just about nobody else on earth. And so you might want to make additional notes. So you can make the notes right in the notebook, and I'll show you how to do that right now. And then you can save it, and then you can upload it to your own GitHub, so you have it, you have your notes nicely saved. That was the reason to ask you to actually do it in that particular fashion. So having said that, it's up to you how you want to do these labs. These are remember, one of the things I asked you to do is to actually fork it on GitHub, and I'll come back to that in the second hour. But the idea was that these repositories will belong to you, and you can do whatever on earth you want with them, including mothballing them once you're done with the course. Okay, so let's click on Lab 1 Python Pandas. And depending upon your operating system, you might have to click or double click. Just double click to be sure. I'll make this a bit bigger. And you should now have this lab over here. And just to make sure about things, you can run this, and you probably may get an error because you don't have Seaborn installed. So I'm not going to get an error. If you have Seaborn installed according to the instructions from yesterday, then this will not give you an error and this will just run. But if you don't have Seaborn installed, this might give you an error. To install Seaborn, open up a cell above. So the way you open up a cell is go to the first cell. So you can click on any one of these cells. You see this? So you can go to the cell up there and you hit the plus button. That opens up cells for you. If you want to kill these cells, just go on any of those cells and hit the scissor up there in the menu on the top. So let's go to the top here, hit the plus, and you're going to get one of these cell spaces open up for you. Now, if you look right at the top of this thing there, it says code all the way up there. That's telling you that this is a code cell. You can type in Python code in this. If you click the drop down there are different things you can put in the cell. One's a heading. You may or may not have that. Heading's is being phased out. So in your particular version, it may not be there. But there should be a code, a Markdown, and a raw NV convert cell. Let's first look at Markdown cells. Markdown cells are cells basically in which you write notes. And the notes are used in this particular, if you like, sub-dialect of text files called Markdown files. If you do a Google search on Markdown files, it'll tell you the syntax. But basically, the syntax is really simple. You can make headers using pound. And then you just write text the way you would normally write text. And to see what this looks like, you must hit Shift Enter or click on the triangle button. So here I clicked on the triangle button, and my little cell went away, and it said this is text. It's a good question. That's very interesting. Let me try something which, yeah. No, it shouldn't. It's in the code cell. That's a bit bizarre, actually. I've never seen this behavior before.
You need a space.
Yeah, no, that's not the problem here. This should work. That's how I wrote this. Look. Maybe this will go away too. Something's just wrong in my browser. No, this one is fine. That's kind of weird. Are you guys having the same problem, or? Let's be a little bit more clever here. Let's try it here. You don't have the problem?
Sorry that we weren't all born with a silver spoon.
Yeah, we may have actually found a bug in the software. It seems to work down here for me. Try it below the first code cell. So go here, click on that, put a plus, convert that to Markdown. Let's make it make a header. Yeah, I have no problems later. So I may have never tried to do this like 2 header things one after the other, so might have actually triggered a bug.
Maybe it's a feature, right? They don't only have 2 heads.
Maybe, but that's a little bit. I don't know. That's they shouldn't be making that choice. I don't think they did. I think there's a bug. Okay, so let's not work there. We'll go to the one below and we'll work in it. Okay. So depending upon the number of pounds you put in, that'll give you a different leveled header. 1 pound will give you something really big, 2 is smaller, 3 is even smaller, and you can actually see it in the way it even looks at. As I put more, it looks smaller and smaller and smaller. And now you can start typing anything in here. If you put 1 line of space in between stuff, it will put it in different paragraphs. Otherwise, even if I put a new line, let's see what this looks like. Again, hit Shift Enter or hit the triangle. I'll put it all in the same line. So you see there are 2 separate paragraphs over there. Okay? You can use mathematics in this as well. To do mathematics by itself on a line, put $2 like that. And let's say I put alpha. People who have used TeX or LaTeX before should be familiar with this. Otherwise, the way typically you want to write mathematics in the scientific world is when you want to write alpha, you write \alpha, beta \beta. If you want to do fractions, you do /frac. I'll show you, for example. So alpha plus /frac. Which is saying divide beta by gamma, the fraction of beta with respect to gamma is equal to delta. So let me hit return, a shift enter or shift return, and you can see you get nicely formatted mathematics. The good thing about this is it's actually an incredibly good way to write papers as well. If you're being, yeah, go ahead.
Is this only for marking up, or do you also do computation?
With these kind of \alphas?
No, not with LaTeX. I'm just asking.
For the
can you
notebook?
also do computation in the
The
notebook?
notebook, yes, you can do computations. I'll come to that in a second. I'm just telling you about the markup so that you know how to write your own notes if you want to write notes. If you want to write additional stuff to us in the homework, besides what we've asked, you ought to know how to be able to write text. So you create a Markdown cell, you start writing it. That's the way you do math. If you want that math to be in a given line, hello, this is some math. Just do it with $1 on either side and not $2. And I copy that, paste that, and I am crazy. And then it's going to show it to you in line. Again, you want to edit this particular cell, you double click in the cell, and it will bring it up for you to edit. Okay? You want to make lists, you put a line, put a space, start writing, hello, get groceries, get sleep. Hit Shift Enter. It's going to give you a bulleted list. You double click that again to get in. If you want a numbered list, just start putting numbers. Hello. Too many numbers. The actual number doesn't matter. It just needs to be a number followed by a dot. Hit Shift Enter again. I did not leave a space. There you go. So even though I said 100 dot, it put in a 3 dot over there. So, but that's how you create numbered lists. Double click again to get back into that cell. If you want to bold something, hello, I am, put 2 stars, bold, or I am, and you want to emphasize it, and you'll see it while you're writing it too. If you put double stars and you put a single star, it'll start making it italicized basically. Yeah, just 1 second. And if I hit Shift Enter over here, you'll see it as I am bold or I am important. Yes?
What do you do if it's like taking the numbered list and appending it to your bulleted list?
So if you want to, if you want to go one level deep, if you want to nest it,
I mean, like count them falling, because when I do it that way, it's just putting them all as bullets.
yeah, if you have them just one after the other, it'll do that. You need to put some space, like I think two lines of space in between to do it. Yeah, you want 2 lines of space in between them, and it will do it for you. Okay, so this way. More importantly, if you want to communicate any commands that you've written, like in in a fixed font test, you put a back what's that thing called? Back apostrophe? I don't know exactly what you would call it. It's at the upper left corner of your keyboard. A tilde. No, it's not a tilde. What is it? I have no clue what the symbol is called, which is why I'm asking you. No, it's not an accent. It's a tick. Maybe okay. Let's call it a tick. That sounds nicely insecty. So, and I am a tick. And you can see that it actually makes it in a sort of like a fixed width font, sort of like indicating it's a command. So typically, when I say when I want to write do a git status, I'll put it inside this.
Backload.
Backquote. Okay.
Or backtick.
Or backtick. If you want to do a lot of this, you can just if you want to put things quoted. And miles to go before I sleep. That will put it in a slightly quoted format. It's kind of useful to make things look kind of important, or just to quote somebody or something of that sort. And you just put a left arrow and a kind of greater than symbol, and then you start writing over there. And finally, if you want to write code, you can do something like this, I believe. You can say 3 backticks or 3 backquotes. Put the language you're writing it in. In this case, let's say Python. Let's write a Python function. And then at the bottom of it, I'm going to go back and put 3 more quotes. And if I hit Shift Enter, it's going to give me a nicely syntax highlighted Python function. So if you want to communicate Python functions, you can do this as well. So this is a basic idea of Markdown. I'm not going to go into it in any detail. You should do a Google search, and especially a Google search on Markdown in the IPython notebook. There are many, many more things you can do. The IPython notebook has the ability to export whatever you see out here in different formats. It uses the command IPython nbconvert, and some of it may work from your menu out here. So download as HTML, Markdown, PDF via LaTeX, but then you need to have an entire LaTeX system set up and so on and so forth. So that's for the people who know what they're doing. It's kind of beyond the scope of this class. But you can export these in different formats, and you can write papers directly in it, which is why it's a very interesting interface. In fact, a lot of papers, at least in the field that I work in astronomy, these days are written right inside the IPython notebook, because you can have the computations right there, and then somebody can go and replicate what you did, which is kind of important. Especially, I mean, I think some of you have probably heard about the new papers that came out, like a bunch of experiments with p-values just could not be replicated in psychology and some other fields. It's kind of, these days, actually journals are starting to ask for the code so they can make it available for replicating things. Okay, so that's just a quick introduction. Now, if you want to save the work you've done out here, dirty as it looks, basically, you hit the little save button, and it saves it. Actually, the IPython notebook saves for you from time to time, but after finishing any reasonable chunk of work, I would always hit the save button just to be on the safe side. Better safe than sorry in this kind of situation. Okay. So going back to that little cell we created at the top out there. Remember, I went up here and I created a cell by hitting the plus button. So how many of you have already installed Seaborn? Probably a few, right? Okay, if you haven't installed Seaborn, and especially on the Mac, this should be a one-liner. Just hit an exclamation. So by the way, it's one very useful thing on the Macs at least. And I don't know if it works on Windows. Those with Windows boxes should tell me if it works on Windows. You hit exclamation and then you just provide a command. So in Windows you could do dir. In this case you could do ls, and ls will tell you all the files in this folder. What does the syntax mean? The exclamation means just run a command on the system, a command on the shell. So you can run any command. We want to install Seaborn, so the command we want to run is exclamation, which says run a command, and the command we want to run is pip install. Pip is the Python package manager. I don't know what pip stands for, but it's the Python package manager. Pip space install to install, and we want to install the package Seaborn. And that's what you want to run. If you do have two Pythons, and you were one of the people like me, where pip was not in where IPython was not in my path, right? Remember on the shell when I typed IPython, it said where is IPython? You must provide the full path to pip. In my case, it is anaconda bin pip. Otherwise, I'm actually going to land up installing Seaborn on Apple's Python, which is not useful for you in this notebook. Okay, so that's a critical thing to kind of remember. So either run anaconda bin, if you put it in /anaconda or in ~/anaconda, depending on where you installed it, or just do pip. Most likely what you're doing will actually work right off the bat. You do that, it's going to think for a while, and it tells you the requirement already satisfied because I have already installed it. For those who haven't installed it, it should think a bit. It will actually go and fetch it from the internet and install it on your system. Yes?
The issue of headers not working?
Yeah, it turned out, I think we actually landed up triggering a bug. So to get the headers working, I just went 3 or 4 cells down in the notebook, and I hit plus. I created a cell over there, converted it to a Markdown using that menu at the top, and the headers just worked. So this was some bizarre bug, and I almost bet you that maybe people who are using who are using Chrome don't have it. This might be a Safari with the IPython notebook bug. Anaconda by default tries to open up in Safari. You may want to actually run in Chrome instead. Your mileage may vary. You have to try out these various browser combinations. It's operating system, exactly which version of Safari, which version of Chrome. One of these will work for sure. Yeah?
It's actually, if you type in a header that says header, then it doesn't type the header. If you type it in any box and you found header, then it doesn't type it. So I was just messing with it.
Oh, so what you're telling me is that if I was to do this on the first cell itself, so, and not type type something random, it'll work. Yeah, okay. But header won't work. Whoa, that's random. That's kind of cool. I didn't know that. Headers? Headers will work. It's very random. Okay. So if I'm assuming that most of you were able to install Seaborn by this technique, if your Seaborn didn't install properly, this next cell that will run will barf at you. So now you take your pointer, put it inside this this big cell over here. You can see that the focus, this line becomes a bit dark, indicating that you've actually got the focus inside the cell. And hit Shift Enter, or hit the triangle button on top over there. And it's going to think for some time. In my case, because I'd already done it, it didn't think for a very long time. If you got an error out here, that means something is either wrong. If you got an error on Seaborn, that means something is wrong with your Seaborn install and everything else is okay. If you got an error before you got to Seaborn, that means something is hosed with your Anaconda installation and you should come see me after. And we'll try and figure out what's going on, basically. Okay, so let me explain. This is the incantation we're going to use in almost every lab, in almost every lecture, throughout. You're going to use it, and it's not a bad incantation for data science. So let me explain. It's worth explaining a little bit of what's going on exactly with this incantation. The first line here, percentage matplotlib inline, basically tells it that I want to have the graphs that I'm going to draw show up in the notebook interface. I don't want them to be outside. Because you can have it so that it's outside as well, which is sometimes useful. How many out here have used RStudio? So folks that have used RStudio know that there's this bottom right cell in which the plots start showing up. That's kind of the idea in which you have this outside. There is, by the way, an RStudio-like interface called Rodeo, which actually includes the IPython notebook, which you may want to try out if that works better for you, if you're familiar with RStudio. So that's another option you have for running the IPython notebook, for those familiar with RStudio. Okay, so the packages we'll be using in every lab, and you'll be using in every homework, are NumPy. NumPy is numerical Python. What it gives to you is a fast list or fast array object, which is actually written under the hood in C. It's not written in Python itself. It's extremely fast, extremely good in the way it uses memory, and it's the basis for everything. Everything is built on top of that. The second import is SciPy. It imports a lot of things for you. It gives you like statistics functions, normal distributions, binomial distributions, and all of those kind of things. Optimization functions, everything that actually needs to call an optimization, to maximize something or to minimize something uses SciPy under the hood, so you need to import that. The third thing is the plotting library. Import matplotlib as MPL, and you will need that from time to time. The fourth thing gets color maps, and you'll see a syntax. One of the things you'll see about the syntax, it says import NumPy as NP. And that's because if I'm going to use NP, NumPy again and again and again, I don't want to keep typing NumPy. It's 5 letters. So it's NP, just to type 2 letters instead of 5 letters. By the way, this is a standard incantation. Everybody in the field uses this. So it's good that you actually use this. Because you will see code which says NP dot something. And you'll be like, what on earth is NP? And now you know, NP, everybody uses NP for NumPy. You could have said N, but nobody uses it, so don't. Okay? There's nothing, that NP is completely something that you put in there. It's not something in the system. It's the way you named it. Import SciPy as SP, matplotlib as MPL, matplotlib.cm. So that's a color map, the module inside the matplotlib library, and you're going to import that as CM. This one is the most important, matplotlib.pyplot. That's the thing which helps you do any of the plots. Okay? And so you're going to import that as PLT. Yes?
If we didn't specifically import matplotlib.pyplot, would it have been imported with the original import matplotlib? Or are we just importing it now to create the shortcut PLT?
We're doing it to create the shortcut PLT. You could have totally done mpl.pyplot. something. Yeah, you totally could have done mpl.pyplot. something, but then again, you'd be typing a lot of stuff. And everybody uses PLT. So you use PLT. Import pandas as PD. Pandas is the library we're going to talk a little bit about right now. Pandas is the, for those who are familiar with R, pandas is data frames in R. And you can go home. That's really everything works that works in data frames works in pandas, and you know what you're doing. But import pandas as PD, again, that's the convention. The next three ones are not necessarily required, but they're just to set up some display options. I wanted to keep the display width a little bit wide, have at least 100 columns show with a scroll bar, and I wanted the pandas tables to be output as HTML tables inside this interface. Not particularly important. You'll see what it's doing later. The rest, the stuff above it is critical. Nothing will work if you don't have that stuff. And then lastly, I'm importing Seaborn as SNS. Seaborn, by the way, is not entirely critical. You can get around Seaborn by doing stuff in Matplotlib, but it makes things so much simpler that it's actually worth using. So it's good to have it, and it makes things much more beautiful. The standard Matplotlib defaults are really, really ugly, and this makes it much more beautiful. And Hans-Peter will have a lot to talk about that this coming week, on Thursday, I think, actually. Okay, so Shift-Enter that cell. And then let's go down over here to this little thing that says pandas. So I have a little cheat sheet. I hope this link still works. Yeah, there are a bunch of cheat sheets over here. And so there's a reason I put up this link. There's a cheat sheet for Python, there's a cheat sheet for Matplotlib, and there's a cheat sheet for pandas data frames. It's worth downloading those cheat sheets and keeping them by your side because they have a good amount of stuff, useful commands that unless you are already a Matplotlib programmer or a Python pandas programmer, you would not know. So useful piece of stuff to click on and get things. Okay. Now here is where the first thing you're going to see is reading a spreadsheet-like file. So CSV files are comma-separated value files. I'm presuming that everybody here has used something like Google Sheets or Excel or Numbers if you're on the Mac or any kind of spreadsheet program. Normally, the spreadsheet programs save their files in a proprietary format, but all of them have the ability to export files as comma-separated values. So dirty secret of a lot of data science is that we use comma-separated values for almost everything. It's a very good format. There's a lot of good parsers that have been written to deal with them. And so you'll find lots of files which are in CSV formats. And to read a file in a CSV format into pandas is incredibly easy. You just hit pd.read_csv, basically, all.csv, which is the file. And if you got this folder down, you should have all.csv. By the way, if you don't have this folder, if you're following along on try.jupyter.org, or if you're following along on some other online thing, like maybe you got the binder to work, you want to replace that all.csv by the appropriate link for it. And let me just show you how to do that in a second. So here is my GitHub link to this. All.csv is in here. I can click on it. It's a big file, so GitHub is not going to show it to me. If you have small CSV files, GitHub will actually show them to you right in the interface. So you can see what your table looks like by just putting it into GitHub. You're going to click on View Raw, and that's going to give me the CSV file over here. I'm going to take the link up here. I'm going to copy it onto my clipboard. I'm going to go back to my lab over here. And where it says all.csv, I'm going to paste that down. Pandas is smart enough, it'll actually go to the appropriate URL, and it'll pick up the file from there. So you didn't even need to have this local. The reason I'm of course showing this to you is that some of you might be working on try.jupyter, in which you haven't actually uploaded the all.csv. And so to be able to do this, you need to be able to get that link. And so now if you hit Shift-Enter over here, It's going to go boom, boom, boom. It's going to go get it down. It's going to save it in some temporary spot. And then it's actually going to open it. Now, let me tell you what some of the other things are. Sometimes CSV files have headers. Right? If you actually, most of the time CSV files have headers. If you export it from Excel or numbers, the column names come as the first line of the CSV file. When the column names come as the first line of the CSV file, then you know what each column corresponds to. In this particular case, I did not save it in that particular fashion, but I actually know what the columns are. So I tell it header is equal to none. I say I have no header line. Start thinking that the first line is data. Okay? And then I tell it what the names are. These are the various columns. I scrape this data set so I know what they are. That's why I just put them there. Okay? And then I say df.head. What head does, if those familiar with Unix will recognize head from like the head command in Unix and the tail command in Unix, the head command gives you the first 5 lines. So in this case, it gives the first 5 rows of data. So here you can see the first 5 rows of data. These are, so I should tell you a little bit about this data set. This data set is from Goodreads. Goodreads has this section on which has this bunch, has a list basically, saying these are the best books on our site. And they don't tell you why they are the best books on the site. They have some proprietary algorithm that says these are the best books on our site. So I went and scraped those. And the stuff you get from them are things like ratings, the number of reviews, ISBN of the book type, the author URL, the year, the genres. And I did something to put it into this particular format. And the rest of it's really stuff which has something to do with how I scraped it, so it's not kind of important. There's a rating count, how many people rated it. Okay. So basically, what you're seeing out here can be thought of in 2 different fashions. It can be thought about as a bunch of rows pasted together, right, to make a spreadsheet. Or you can think of a spreadsheet as a bunch of columns pasted together. The way Pandas thinks about it is as a bunch of columns pasted together. So this little graph is actually from that little cheat sheet that I pointed you to. And it tells you that what's happening over here is that Pandas basically has these columns. And it creates what's called a series for each column. And a series is a list-like object. Okay? So it's something which is kind of listy. You'll hear me say this quite often, this kind of notion of listy. And Python has this kind of thing, which if you're familiar with programming is what's called duck typing, which means if it quacks like a duck, it's a duck. So if something looks like a list, it's a list. And everything that you could probably do with it, which you would do on a list, which add things to it, remove things from it, concatenate lists, will work for it. So a Pandas series basically behave like lists. There are many things in Python which behave like lists. Files, for example, behave like lists. Once you open a file, you can read each line out of the file as if the file was a list, where each element of that list is a line. So files behave like lists. Lot of other things. I won't go into them right now, but the creators of Pandas wanted you to be able to treat Pandas as a bunch as a set of lists. So basically, this is a list of series, each of which is a list. So it's a list of lists, which is not surprising, right? That's what a 2-dimensional array is. It's a list of lists, basically. Okay. Next important command to know over here is dtypes. Dtypes, yes.
Output results from multiple functions within one cell.
Absolutely.
So I was just trying df.tail and then df.head, but it only gave me the output for the head.
Right. So the reason that happens is because what you're saying is, suppose you did the following in any one of these cells. You said A is equal to 1. Okay, so let me open up a cell and I'll tell you exactly what's going on. So I'm going to open up a cell here, and I'm going to say A is equal to 1. And I'm going to hit Shift Enter. It's not going to give me any output, right? Simply because it's an assignment. I assigned the value 1 to A. So it's not giving me any output. If I want to see some output, I'm going to have to put A after this. And then it's going to show me 1. What's actually happening under the hood? It's a very good question, because what's happening under the hood is when you say A over there, what the IPython notebook under the hood actually does is something like this. You get identical output. So if I was to say A is equal to 1, B is equal to 2, A, B, it only gives me the last one. It doesn't give me the previous one because it's not on the last line of the cell, it does not interpret A as print A. It just interprets it as A. And in the language, just putting the name of a variable absolutely does nothing for you. It's kind of like almost a no-op. You just, what's A? But you didn't ask me to print it. You didn't ask me to do anything with it. So if you want this explicitly, you'd have to do this. And then you can see it puts it at different places. The A is printed up there, and the B comes in the output. So it's the way it's treating it. So by default, if you just put something on the last line, it treats it as the thing it wants as output. So that's the answer to your question. It's a good question. You might get tripped by it. If you want to be very explicit, sometimes it may be better doing this. Print A and print B, basically. But typically, if you're just looking at one thing from a cell, you could also do something like this, which is, by the way, Python notation for putting things in a tuple. So it'll put the outputs into a tuple for you. So there are different ways. Your choice, how you want to output stuff. Okay, so we created this data frame. We saved the data frame into this variable called df. We did df.head to look at the first 5 lines of this data frame. Now, a data frame is this df is an instance. So those who are familiar with object-oriented programming will recognize that a data frame is a class, and pd.csv is something like a constructor. We created an instance df of the data frame class and displayed it to you by doing df.head, basically. But because it's an instance, it has properties and it has methods. Methods are functions that belong to objects. So you can do df dot something, and that's the notation by which you do it. So df dot something. So for example, one of these things is df.dtypes, and dtypes is just short form for data types. And what it's going to do is it's going to tell me the data type of every column. And the way it tells me the data type of every column, I told it nothing, right? I just gave it a CSV file. I didn't tell it anything about the data, is that it kind of statistically infers what data is what inside this thing. So if I do df.dtypes, it tells me that the rating is a float 64 and the year is a float 64. For some reason, it thought that the year is a floating point variable rather than an integer. You know, if 1971, that should be an integer. The rating is a floating point variable, right? Because if you look at it, the rating is going to have like 4.40 or 4.41. It got that one absolutely right. It inferred that one correct. But it got some other ones completely wrong. Like review count should have been an integer. Instead, it's an object. An object is the catch-all for something that looks like a string over there. So something's not quite right about this. And anytime you see a data set, this is the first thing you'll ever do to clean a data set. Look at its types and look at the inference it makes for these types. Because there is information in this inference. The fact that the rating count turned out to be an object, what else? The review count also turned out to be an object, tells you that something is not entirely right with those columns. And we'll figure out what's not entirely right in a little bit. But this is roughly the first thing you should do. You should first start thinking, I've been given data, is it any good? 9 out of 10 times it will not be good, and you'll have to clean. So that's the first thing that should come into your head. But right now, I just wanted to show you that this is a property of the data frame. You can find out the types. You can also find out the shape of the data frame. If you do df.shape in the next cell, it tells you it's a tuple of 6,000, 10. It's telling you the rows and the columns. It's 10 columns, 6,000 rows. And it's basically telling you the shape of that data frame, matrix, whatever you want to call it, right? Spreadsheet. To get items, to get these individual values from a tuple, you do the kind of thing, the thing that you might think is obvious, which is you basically give it an index. So df.shape, it's a tuple. I want the first element of the tuple. I do df.shape of 0. I want the second element of the tuple, I do df.shape of 1. And this is, of course, the never solved great debate in computer science. Should languages be indexed starting at 0 or should languages be indexed starting at 1? If you're like me, who learned Fortran as his first language, way back in the day, I'm dating myself now, it's funny. I mean, in physics, people still use Fortran in a big way. Actually, Fortran is the most efficient language still to write scientific programs in. And a lot of the code that goes into the linear algebra libraries that are used by Python under the hood in NumPy and SciPy are actually still written in Fortran. And they are because they've been written for 30 years and they've been debugged for 30 years. There are absolutely 0 bugs in those things. So everybody still uses them. So Python, on the other hand, gets its lineage from C, Java, and all of these other languages, where the first element in a list is the 0th element in a list. So you're going to have to get used to this. And a tuple, by the way, is a kind of list too. That's why you can do the 0 and 1. The only difference about tuples is that once you create a tuple of a particular size, you can't change the size. So you can't, for example, add another thing to a tuple. And the reason for that is this way it becomes incredibly efficient. It's a fixed size thing once you created it. So here there are 2 elements to this tuple, and you can get the first one and the second one. I converted back to a tuple by doing it this way, but I could have just done df.shape of 0 here, and it would give me 6,000. You can get the names of the columns by just typing df.columns. Again, it's an instance variable of this data frame. Python has a built-in function called type, which tells you what type anything is. So you can do type of df.rating. So this is the first time, by the way, you actually see a column. And you access columns just like instance variables. So if you remember, one of these columns in the spreadsheet was rating. If you want the values which are just in the rating, you do df.rating. Let's do that. Let's see what it looks like. So I'm going to open up a cell below this markdown cell here. As the diagram above shows, I'll hit plus, I'll open up a cell, and I'm going to type df.rating. And you'll see this object show up, and it doesn't print all of it. It puts this ... in the beginning because it's huge. It's got 6,000 things. And it says the name is rating, the data type is float64, but it actually gives you this little index on the left. The 0th element is 4.40, the first element is 4.41, basically. That's called the index in Pandas. And if you actually do a type on this, type on df.rating, you'll see it's called it's a series, basically. It's a pandas.core.series.series, basically. So that's the Pandas series that I was telling you about, which acts like a list, essentially. And the type of df itself, the entire thing is a data frame. So if you're ever wondering what's going on, here's a variable, what kind of bizarro thing this is, just to type on it, and it'll tell you what it is. And then once you find out what type it is, this is a series, this is a data frame, you can just copy and paste this from here, put it on the web, and you'll get intro to data structures, Pandas documentation, and then you go off and read it, basically.
Does df.columns work if you don't manually specify the column names?
It does, yeah. If it inferred the column names from the first line of the file, it'll still work, yeah. So one thing that's actually 2 things that are critically important. You really don't need us in this course at all. Actually, you don't need any of the professors or anything. You just need 2 things. This is a kind of slightly funny statement to make because I'm here in front of you. But you need to be able to use Google really well, which I think you know already. But more important than that, you need to be able to use Stack Overflow very well to solve your problems. Somebody once said that a programmer is a device for converting Stack Overflow answers into code. And it wasn't, at least for me, that isn't too far from the truth. I usually actually type in words, you know, how to square a column or in Pandas or something into Google, and voila, there'll be like a Stack Overflow answer for it. And I'll go in there, I'll see what the code is, and I'll use that code, basically. So Stack Overflow is really one of the best things that's happened in the last 5 or 6 years in terms of programming. It just makes things so much easier. Okay. So let me do one or two more things with Pandas, and then I just want to actually go on to Git a little bit. And then you can continue, running this at your leisure. And at the sections as well, as you run it, you're going to run into problems. Ask those questions at the sections. The way the sections, by the way, have been set up is that there are 2 hours. The first hour is a kind of mini lecture kind of thing where somebody will actually do the same thing I'm doing right now. Again, at the section, but it doesn't have to be so. You can go to your particular section, find a consensus with the rest of the folks who are at the section, and tell your TF at the section, yeah, that stuff about loading CSV files, we know all of that. The stuff about querying, we don't understand it. So please explain that in more detail. And they'll do that, okay? So in querying, but the flip side of that is that it's really incumbent upon you between the Friday, actually the Thursday night when these lab notebooks will come out, and the Friday when the video comes out, essentially, and maybe you watch it, to watch the video or at least do the lab notebooks until that Monday or until the next point when your section is. Of course, those who have the section on Monday have very little time. So it's not entirely fair to them, but that's just how the cookie crumbles, so to speak. Those who have it on Friday have a lot of time, of course, but I wouldn't wait that long. Okay, so querying is the really important part of Pandas, and it's a really simple part of Pandas. So basically, the way querying works in numerical Python as well as in Pandas is really simple. It works on what's called a Boolean mask. So what you do is you take a big list of things, okay? And you test each one of those things under a certain condition. So let's say I took this data frame and I just take the rating variable out of it, and I only want to know the really poorly rated things. So that's what I do over here. I say df.rating less than 3. And what that's going to do is that it's going to go one by one through that entire list of df.rating, which we saw earlier over here, this entire series. It's going to ask for each one of them, are you less than 3? If you're less than 3, return true. If you're not less than 3, return false. And it's going to give me an entire set of trues and falses. So if I do that, I'll get an entire set of trues and falses over here. Here, a lot more falses because most people tend to be actually generous with their ratings and not give ratings less than 3, but you do see there's one true over here at 5979. Well, what this has done for me now, it has created for me a new list. And this new list is basically what's called an indexing list. It's a bunch of trues and falses. It's false, true, 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 false, false, false. I can use this list to index anything which is of the same size now. So what I do in the next line over here, well, I don't quite do it, but what I can do over here is I can just go and say df, give me the entire data frame, but give me the entire data frame indexed by those which are true inside there. So I can do df of df.rating less than 3. So I'm basically putting that entire list inside, right? Inside this, and I'm saying only give me those which are true, and that's what's Boolean indexing. And everything in NumPy and in Pandas works on Boolean indexing. So you should get this concept down. That this is only going to give me those which are true, those rows for which this is true. So if I do this, you can actually see there are 4 things with ratings less than 3. I'm actually curious now. Okay. Well, and I have to say this is not a representative data set, right? Because this is the top like 6,000 best books. But even then, some reason I think they put Mein Kampf into that list, even though it has such a poor rating, because it's an important book, even if it's a poor book. But apparently everybody thinks it's a poor book. Okay, so that's getting the entire data set. But you may not want that. You may want to say, oh, I don't care about all the rest of this stuff. I just want the review counts for these. You can do this instead. So that's taking the series df.review count, right? Remember just that column, and saying only give me only return those for which that value is true. And if I do this, it just gives me those 4. Of course, it's still 4. Pardon me? The index is in brackets, right? So the indexing part is here. The indexing part is there. The df.review count is basically just that series. And that's why you only see the things corresponding to that series. It's not particularly easy to read this in general. So what I typically tend to do is I create a new data frame, which is a sub-data frame of that data frame, and then get these values out. So my way of doing this would have been actually to do this. So let me call that df sub1. That's my sub-data frame. And I'll do df sub1.head. It's only 4, so all of them are going to show up anyway. That's going to give me that small data frame. And then I'll go df sub1 dot, what was I trying to get? Review counts, right? And that'll give you exactly the same result. Yes?
Is that table formatting automatic?
Yes, this table formatting is automatic. And it came because right at the top, remember I said I want to set things to view in HTML? That's why it looks like this. It's kind of useful to be able to see it in this particular fashion. Okay. It's kind of useful to sum up the ratings as well. If you do df.rating less than 3, and we saw that there were 4. It's kind of obvious. But you can just do np.sum. Now here you're seeing some of the programs which are in the numerical Python library, some of the functions which are in the numerical Python library. Sum is one of them. It basically sums things. And here you can see that there are 4 of them. It just basically sums things. And you're going to be wondering what on earth is going on. Remember when we did that df.rating is less than 3? I had a bunch of falses and some trues. I had false, 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 true. What the hell does it mean to sum falses and trues, basically? And you can actually see how that works. And it works by, if you do 1 times true, that gives you 1. If you do 1 times false, that gives you 0, the way Python works. There's a little trick going on over here. True has kind of like, if you like, the value 1, and false has the value 0. So when you do a sum, it basically sums 1s for each time you saw true, and 0s for each time you saw false. So really what happened out there was when you did np.sum on this, when you did this particular thing over here, it said, oh, false, 0, false, 0, false, 0, and 0 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0, 1, plus 0 plus 0 plus 0, 1, and it went on to 4. Okay, so that's why you got this np.sum. So you're like, okay, I want to calculate now the fraction of things that had this poor less than 3 rating. So you do what you think is the obvious thing. You do the sum of less than 3, and you know there are 6,000, and you know how to get those 6,000 out. It's df.shape of 0, right? It's the number of rows. So you divide one by the other, and you get 0, which was patently wrong. There were 4 out of 6,000. It's close to 0, but it's not 0. Does anybody know why?
It's just dividing integers. So
It's just dividing integers, right? So it's, by the way, that's changed in Python 3. So you'll see that if you do this in Python 3, you'll get a different answer. But most programming languages, if you divide 1 divided by 4, won't give you 0.25. It'll give you 0, because that's integer division. It's like your long form division. You'd have a 0 out there and then a remainder, basically. So you want to be careful of that. You don't want to divide 1 by 4 in that particular case. You want to divide 1.0 divided by 4.0. And you can see that very clearly. If I do 1 divided by 4, 1.0 divided by 4. One of them gives me 0, the other gives me 0.25. So at least one of those needs to be converted to a float, to a floating point variable for this to work. And we do that in the next step here. We get the sum, we're keeping that as a sum, and we're just taking the denominator and converting it to a float by just putting the Python's float function around it. And that gives you the actual fraction.
There's no float division?
I think you can do,
You can import something.
yeah, but in 2.7 you may be able to do this. No, it doesn't. This works in Python 3 though. So the answer is no. Not that I know of. That doesn't mean no. It's not that I know of. But if you think about this a little bit, you'll realize that there's a far easier way to do this, to get this fraction out, and that's to basically find the mean. And the reason that works is because what's a mean? It's basically the sum divided by the number, right? And so you could just do mean instead and let this floating point business be taken care of by numerical Python for you. You don't have to worry about it. So you just do np.mean of df.rating less than 3.0 and voila, it actually does the right thing for you. Now this trick, by the way, you'll be using it again and again and again and again and again and again and again in data science. Because what is this mean telling you? This is a sample of good books. Presumably, it's talking about some population of good books. What does the fraction of books with ratings less than 3 tell me? Think about probability. Give me an answer in terms of probability. Exactly. If you sampled at random, if you sample the population at random, it's the probability that you'll find a book with a rating less than what? Less than 3, basically. And it's a really low probability that you'll find that, but that's the probability. So in other words, I've used this sample estimate. It's an estimate. Remember, it's an estimate of the probability from the population. It's just we only had one sample to play with. But you're looking at this population of books, and in this population of books, the probability that you have a rating less than 3 is 0.006. So this is a trick you'll play again and again in which you'll actually take a mean value of a fraction, right? It's basically a fractional value. It's a mean value, and you think about it as a probability. It's a game you'll play again and again. So that's why I wanted to sort of point it out to you. Of course, with the flip side of playing this game comes a responsibility with it, is actually understanding what your sample is. This is a sample of books that Goodreads thinks are good. So it's kind of a not very good population to talk about. It's not representative of any kind of samples you might want in the real world. What we should have actually done for this particular case, if you wanted to think about it in terms of a probability in any reasonably sensible fashion, is actually taken 6,000 books at random from Goodreads, right? So we get all the IDs of books on Goodreads, take 6,000 books at random, go and fetch the information for those books, go and scrape the information for those books, and then look at what it is less than 3. And then I can make a statement if that less than 3 came to like a probability of 0.1, that 10% of books on Goodreads are poor. So it's very important to understand what your samples are. So anytime you start working with data, that's the second thing you should keep in mind. All data you look is a sample of a particular population. What are the characteristics of this population? Okay, so that's kind of, I mean, it's like saying, let's take the IQ of all the students in this class. It's likely to be fairly high, and say that's the IQ of the American population. Not a good inference, right? So, okay. In Pandas, you could do this even simpler. You can just take that df.rating less than 3, put it in brackets, and then do .mean. And because it's a Pandas series, and series have means defined on them, and which means you can also do things like this. df.rating .mean, and so on and so forth directly. You can do df.rating standard deviation, and boom, you can get means and standard deviations right off the bat. Okay, so I'm going to stop here. Yeah, I'm going to stop here, and you can see you can do the filtering. I'll just talk a little bit about this. You have df.query rating greater than 0.5. That's another way of doing what I just showed you. You use the query, and then you can write it in kind of like Englishy kind of fashion inside quotes. I still prefer this one, where you actually get the Boolean thing and you put it inside. It's just kind of clearer for me in the head to do that. Your mileage may vary. It's kind of fun, though, to do this particular one, to see years less than 0. I was a bit confused by this at the beginning, and I realized, of course, that it's BC and AD. And then you can see which are the books which are the good books. And then if you need to actually combine things, which is something that comes in quite often, basically. So here I've looked for all those old books which have ratings greater than 4 that people thought were actually good. And so the way you do this is that df.year less than 0 gives you this series of false and trues, but you put it inside these brackets to sort of like put the scope so that the scope in the language works properly. And then you use ampersand. And what that ampersand is doing is it's basically doing an and. So, and then the next one is df.rating greater than 4. I'm looking for all books with the rating greater than 4, and I'm looking at all books with the years less than 0. So what is it going to do? What this is going to do is that this is first going to look at the entire data frame and give me those which have the year less than 0. Okay? And that's going to be like false, 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 true, 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 false, 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 false. Then this one is going to give me all of the ones which have a rating greater than 4, of which there will probably be quite a few because people are lenient. So it's going to be true, 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 false, 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 true, 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 false, false, false. So for each one of these, there's going to be a true value and a false value, or a true or a true. So there are 4 possible combinations, right? There's true and true, true and false, false and true, false and false. Only true and true gives you true. Everything else gives you false. So when I combine these using that ampersand operator in between, is going to give me a set of not too many things, because there's only 1 out of 4 ways in which you can get true and true giving you true. Everything else gives you false. And when I do that, it's going to give me the data frame that corresponds to this. And you see there are a few books. I tried 4.5 first, thinking that in the older the books, they might even be better, but apparently there were none. And these are the really good old books apparently we ought to be reading. Okay, so that's where I'm going to stop. The next thing is actually fairly important. It's cleaning. Remember those D types were, actually I should spend a second on this. The D types were not what you thought they were. So in cleaning, what you do is you make them be what you think they are, and that will tell you what the mistake is. So let's look at review count and rating count. Those should have been integers. They're not. Let's force them to be integers and see what happens. So what I do to force them to be integers is I say df.ratingCount.asType int. So I'm coercing it to be an int, and then I save it into itself. By the way, you might wonder why I'm saying df of open square brackets rating count is equal to df.rating count. In Pandas, it doesn't matter which one of the two you do. You can write it as with a dot notation. You can write it with this notation. But remember that the dot notation won't work if you have some weird symbols inside the column name. Right? If you have a space in the column name. So your column may be funny space people. You can't do a variable in Python which has funny space people. Variables need to be continuous. There cannot be any spaces in them. So then this is a better way of doing it. Also, I found that sometimes Pandas can be a little bit inconsistent, that on the left-hand side, it's better to actually use this syntax. Whenever you're setting something to something, it's better to use this syntax. So I'd advise you in general, use this syntax on the left-hand side of any expression. Df, this particular quoted syntax rather than the dot syntax. Anyway, so what I'm doing out here is I'm taking the series rating count, I'm coercing it to an integer, and I'm saving it back into itself. And you'll see that when you do it, you'll get a major error. And the error it gives you after going all the way to the bottom, usually I go all the way to the bottom first. It says invalid literal for long with base 10, none. This looks a little bit confusing until you realize that ints and longs are just another way of saying this is a big sized integer. Base 10, yeah, we're using base 10 integers. And it says none. There wasn't supposed to be a none. These things were supposed to be integers. So we got an error. And whenever you get an error which says none, that typically means that there was some garbage data somewhere over there. So to look for garbage data, and typically garbage data is something of the type null. You go and do something like this. So it's saying, oh, okay, which one was this happening in? This one was happening in the first one itself. So you can do it for rating count, you can do it for review count, or you could do it for year. Here I did year, but let me do it for rating count. This is the second thing I forgot to show you guys. That if you are, when you're playing around with variables in the IPython notebook, you can just type one part of it and hit tab. And that will give you all possible things that you can do. So I typed R and then I hit tab and I wanted rating count, so boom. And then I wanted to see, is it a null? A null is basically a non-existent value. It's coded in different ways in CSV files. Sometimes it'll just be a space and there'll be nothing inside of it. And Pandas is smart enough, it'll see that this is a space in a place where everything else was an integer, and it will code it as a none. But you need to then go in and look whether they're a none. So let's see what happened here. So again, I'm doing the same thing. I'm going to go to the series rating count. I'm going to ask which one of you are null. The ones that are null will be true. The ones which are not null will be false. So there'll be some of these which are null will come out. Let's see that. There's no problem with rating count as far as null. So something else happened with the rating count. All right, so maybe it was in review count. Let's go look at the review count. And nothing was wrong there as well. So let's go for year. Aha. And this is what you will typically see in these things. It's called NaN, not a number. That's what NaN stands for. And if you look at these, you'll see that these NaNs are not a number. They have rating counts of none in there. So it was actually set it to the string none. And that was probably something I did in my scraping. So I produced some bad data in this particular scenario in my scraping, which you will do too, but you'll have to correct your own error. So here it was not null, it was none, but the year turned out to be NaNs over there as well. So something was really bad about the scraping when I went to those particular web pages. My program barfed at me, and I didn't realize it, and now I need to take it out of this data, essentially, before I can do anything on it. So to get rid of the nans, I'm using the same variable here. You may not want to do that. You may want to call it df new or something like that, just to indicate to yourself that you change things. I go the other direction. Here I said year is null. And over here I'm going to say year not null because I want the ones which are not null. So again, it's the same thing. Now my true and falses get flipped, right? Most of those will come true because they're not nulls, and the ones which are not a number will turn out to be false. So I do this. I look at my shape, and it turns out I lost 7. That makes sense. 1, 2, 3, 4, 5, 6, 7 over there. And now if I do my d-types, no, I'm still going to have, it didn't change my d-types as yet. So if I do df.dtypes, they're still objects. But now when I do the coercion into the type of ints, I don't get a problem because I removed those things which were NaNs out here and which also in the review counts, in the rating counts were nuns. So it turns out that I actually managed to fix everything by doing this one thing. That may not have been the case, right? Because I might have had nans for years in some places where the rating count was perfectly fine and vice versa. And then I would have to clean again. So this is the process of cleaning. You've got to get rid of all this garbage data that you have, basically. And then finally, I can look at the d-types again. And you can see that the review counts are ints, the years are ints, and the rating counts are ints, as you might expect them to be. So that's what you should get when you get a clean thing. You should have the data types come out right. So what's the cleaning process? The cleaning process is first, look at the types. If the types are not what you think they are, something is wrong. Go and try and find out what is wrong using this is null, not null business, or looking for other values. By the way, another way you could do this is do something like this. You can do something not particularly useful for rating count because there are going to be so many of these values, but you can do df.ratingCount.unique. And it's going to tell you all the unique values you have, which here are going to be a lot, so it's not that particularly useful in this kind of cleaning. But if you had smaller sets of numbers, right? If you could take 1 of 10 possible values, and then you had some nuns thrown in and some other stupid strings thrown in, then this would actually pick them out for you, and then you could remove those using the filtering syntax. So that's another way to do it. And then, but once you do all this kind of cleaning, by doing this kind of type coercion and other ways, then you look at the d-types again, and they should be what you think they are, and that's when you know. Or let me put it this way: modulo the fact that the data itself was garbage data coming in, that it didn't make sense, this is actually at least well-formed data that you can do something with. It does not mean that any of your conclusions from it are any good, garbage in, garbage out, basically. But at least you can make conclusions from it, which you could not have done earlier. Okay, so Verena will talk much more about this on Tuesday. I just wanted to give you a little prelim thing because once you start seeing the homework in a week, there's a lot of cleaning that you got to do on the homework and stuff like that. Okay, so let me stop there on the Pandas stuff. We have about 15 minutes. I just want to go a little bit onto the Git stuff in these 15 minutes. The Git stuff is complex. This is actually probably the most complex thing you'll do all semester. So it gets better. The Git stuff is complex for some reasons, and I just wanted to talk about those reasons over here. So what I'm going to do is I'm going to open the other lab, which is lab1 git.ipynb. This is a very detailed document. You should read it really carefully, and you should try out the stuff inside of it. Some people, especially on Windows, were having problems. And the problems had a lot to do with where Git is. So what you need to do on Windows is you convert this from raw NB convert at the top to code, and you actually run this code. And it should work for you. I don't guarantee. There was some posts on Piazza saying it wasn't working. If that was your case, come and see me afterwards, just after now, and we'll try and figure out what the story was, and I can post on Piazza. This worked for me on a Windows 8 machine that I tried it on. Let's put it this way. Does not mean it'll work for you. For people who are on Mac or Linux, on Mac, if you actually set up the link, the symbolic link I was talking about, this should work for you. So what I would like people to do actually is to open up a cell somewhere. So let's just open up a cell over here. And in that cell, using either either this notation, we should be inside this kind of folder. You ought to be able to do something like git status using this notation. Well, this is not a Git repository because I did the zip file. But if you're doing it from within there, you ought to be able to do that. But does this even work for you? Does it say fatal not a Git repository? Or does it say Git not found? That's the question. The two ways in which you could do this, you either do it like this, or I'm going to show you the second way as well, which is what I use largely in this in this notebook, simply because on Windows, this does not necessarily, the first one didn't work for me on Windows. I don't know whether it works for you on Windows. If you get this, it means at least that Git is in your path and things will work for you. If you don't get this, that means you haven't put Git in your path. Come see me afterwards. Or you may have just not set up your symbolic link on the Mac, which you do need to do into user local, because it puts it, I think, the download itself puts it in user local git bin git or something like that. And you need to make it in, you need to take the Git executable and have that available in user local bin, basically. So if you don't have, so how many people don't have this working? Don't see this? I want you to see fatal. If you're using the zip, if you're not using the zip and you've already figured out the clone, you should see the status. So either you should see the status or you should see the fatal. I'm talking about people who are seeing git not found or something of that sort. Command git not found. Anybody has command git not found? Okay, then all of you have git in the, do you have command git not found?
It says git is not recognized as a kernel
Or, okay, so yeah, or something like that. So that means that Git is not in your path, and you're on Windows, right? Yes. So you should try and run this cell and see if you then find it. Over here, there's this little thing over here, which is a raw NB convert. It's after the clone arrow. and try and run that and then see if you still have the same error, right? So that's, okay, so meanwhile, while I have a little bit of time over here, what I would like to do is to just actually, since I have you here, give you the idea of what's going on with Git. You'll be able to follow through this repository pretty easily. But I found, how many of you have used any kind of version control before? So at least some of you have used some kind of version control before. How many of you guys have used like CVS or SVN or one of those, right? Okay. So version control in its simplest kind of notion is a very simple idea, right? We do it all the time when we actually collaborate with each other over email. We'll say, my funky document .1 .doc. And then your friend goes and edits it and says, my funky document .2 .doc. And then it goes to the third person .3 .doc, and so on and so forth. So you do version control in your own way. We've always done this as people working on stuff. What Git does is it takes version control and it kind of puts it on steroids in a very kind of big fashion. As a result, it's a little bit complex, but if you actually understand what's going on in Git, it's actually not so complex. So let me just explain that, and then then you should work through this. You don't need to have cloned lab1 to work through this at all. You could just do it from the zip file, because I actually have you clone a completely separate repository called the testing repository in this lab. By the way, if this does not work in the IPython notebook for you, you can actually do this on the command line, both in Windows as well as on the Mac and on Linux. So if you're using Linux, I really don't need to tell you much about this. The only thing that you don't need to do each time is do the cd/temp testing. I'm doing that because I'm doing this from the IPython notebook. You just do cd temp testing at the beginning and do everything there. That's the only difference if you do it on the terminal. And in fact, you'll be doing all your Git stuff on the terminal. So I actually encourage you to put this on one side and open up a terminal on the other side and do all of this in the terminal rather than doing it inside of this. It may be good to do it once inside of this because you're actually reading what's going on while you do it. So I would say do it once inside of this and then go and repeat the whole thing again, but do it on the terminal so that you actually get comfortable with using the terminal to do this. But the big thing over here is this kind of conceptual thing in Git. And I've generally found that when I first learned Git, nobody told me about these 4 parts of it. And I was thoroughly confused as to what's going on. Because there are all these different commands in Git. There is this git add. Then after git add, there is a git commit. And after git commit, there's a git push. And by this time, I want to go to sleep. Because I just wanted to do version control, and you made me do 3 different commands. And why, right? And so here's the reason why. Here's what happens. Whatever you see on GitHub is what's called the upstream repository. That's what GitHub keeps for you. It stores it on its servers, on their file system. They have the upstream repository for you. So when we do that 2015 lab, CS109/2015 lab 1, that's the upstream repository. When you fork it, you've created your own upstream. So in fact, you now have 2 upstream repositories, one of which was ours, one of which is the one I created, which is CS109/2015 lab 1. But if you forked it, you probably have something like Rahul Dave/2015 lab 1. That's what it looks like. So in other words, these 2 things are what you see here. So for example, here's an example. Let me actually, I want to do that one. Okay, so I'm going to go, I'm just going to type it in here. CS109, right, github.com, CS109. Okay, so when I go here, and I go 2015 lab 1, that's in the CS109 namespace, right? Think of this as a namespace if you like. So that's in the CS109 namespace. When you fork over there on the upper right corner, I may have already done this. Well, let me fork it as not so naive base. It does this. And you can see that it's now not so naive base /2015 lab 1 forked from there. So this is a completely separate repository. In fact, what GitHub is doing behind the scenes, they call it a fork. What they're actually doing is they're doing a local clone on their machines. They're cloning the repository there to there. But now it has a different set of like settings. It has a different set of who is allowed to access it and so on and so forth. In fact, you are now allowed to access it. You own this. This is one of your repositories. So this is one of your upstreams. That's the critical thing to remember. And now you can do various things with this. You could not have done it. You could not have pushed to that repository because you don't have the permissions to. But because you forked this, you can, essentially. So going back to that lab1 Git, not only is there, in general, there's one upstream repository, sometimes there are two. In the case of this lab, there are two. In case of the homeworks, there's only one. And I'll tell you why right at the end. There's a little bit of a trick we're playing with the homeworks. Okay. Then when you issue the git clone command to bring it down to your machine, you have to do a git clone. And you'll be doing this later in this. You bring a copy of the repository down to your local machine. That's the local repository. Okay? Now, if you look at that local repository, and let me show you my local repository here. So I'm going to make this. I didn't want to make two of those. Plus, plus, plus. So here, if I go into CD projects, CS109, and to an LS, and I go over to CD 2015 lab 1. By the way, in the lab, I put in a prompt.sh file. So if you go and look at that, there is something that can actually change your prompt. If you're familiar with terminal prompts, it's a really good idea to change your prompt in a way that actually tells you what your repository is. So this one actually tells me that I'm in 2015 lab 1, I'm on the master of it, basically. So what's actually happening here is that if you look at this file .git/config, actually first let me just say that there's a .git over here. This looks like a folder with all the files. But there's a hidden folder here, which is this .git folder. Okay? Inside this hidden folder, there are two separate things. One of these is called the index, and one of these is called the local repository. There are actually two separate versions of your project are in there. And then this folder itself, which actually has the stuff, is what's called your working directory. That's where all your files are. So if you now go back to those diagrams, you'll see that there are four things over here. There's the working directory. The working directory is what you get when you do the ls. When you go inside the .git, there are two things: the staging area or the index, and the local repository. The local repository is the thing that's a clone of that. And then Git takes it and creates a working directory for you. And the staging area is something called an index. It's an intermediate between the local repository and this. And that's why you have a separate add and a separate commit command. What the add command does is it takes the changes from your working directory and it puts them in the staging area. What the commit command does is that it takes stuff from the staging area and it puts it in the local repository. What the push command does is it takes stuff from the local repository and puts it to the upstream repository. What the clone command does is it takes things from the upstream repository and creates the local repository, creates an index for you, and creates a working directory from you so that you can work in it. There is one more command. There's one more command which is involved in all of this. That's git fetch, followed by git merge, or the combination of the two, which is git pull. But git fetch is the important one. What git fetch does is that it fetches stuff from your upstream repository into your local repository, but it doesn't just fetch the current branch you are working on. It fetches a lot of different branches. And branches are one additional important concept. I'll come to that in a second, but the key thing to remember that there are four separate things, and that's why there are these different commands. And you can work through the commands inside this notebook. But I just wanted to show you that if you actually look at that Git file, so over here, so if you do ls on .git, you'll see a config file over here. And if you look at it, it'll actually tell you that, look, You're on the master branch right now. We saw that I was in the master branch. The master branch has a remote repository, which is origin, which is that thing there. And it gives me some ways of how to merge it. And it tells me that the URL for the remote repository was this, basically. So when you clone it down, you'll have something similar, except that that CS109 over there will be replaced by your username. And that's what lets you push changes into your own repository. Okay, one final thing, and it's really important you work through this. Post questions on Piazza, ask questions at section. Getting Git right is really important. The way we're doing the homeworks is a little bit different. In fact, I have, I think, this flow over here. And the key concept in the homeworks is this thing called branching, basically. And the idea behind branching is that you can have completely different versions of the same code. In fact, they don't have to have anything to do with each other. Has anybody used GitHub Pages? Which is, if you use GitHub Pages, then you've actually used this version of branches. There they create two branches. One is a master branch in which you write your code, and the other is a gh-pages branch on GitHub. If you put anything, any index.html file in a gh-pages branch on GitHub, it will create a web page for you. It's by far the simplest way of creating a free web page that I know of. Well, not quite. I mean, you have to know Git. So, but once you know Git, it's conditional upon knowing Git. It's by far the simplest way of creating creating a web page that I know. And it has got a lot of good features in it. In fact, the entire CS109 website runs off that. We use GitHub Pages, which you can, by the way, see if you go to CS109/2015 and go to the GH Pages branch, you can see our code for the website. So what we're doing for the homeworks is something somewhat interesting. What we're doing is the following. We have the 2015 homework repository. My original idea was that, okay, I'm just going to have you guys fork this repository. The trouble is that if you fork this repository, it'll be completely public, and you'll be all able to see each other's homeworks, and the rest of the world will be able to see your homeworks as well, which is probably not what you want to do in a class. So we went and talked to GitHub. GitHub suggested that we'll give you a bunch of private repositories, and they did. But GitHub suggested that what we should do is we should have one private repository per homework per student. Now, if you do the math, we have roughly 400 students. We have 6 homeworks. That's 2,400 for those four. And the one was, that's 2,400 repositories right off the bat. There's a lot of stuff to worry about. So what we did instead was a much simpler idea. It imposes a degree of additional complexity on you at the beginning, but once you get it, then I think you get the entire essence of Git. What we're doing is we're putting each homework into a separate branch. So you have a master branch which just has the instructions and this and a README file which has this image in it. That's it, nothing more. Then already, if you've been given your repository, you have a homework 0 branch. And to access that homework 0 branch, you just do git checkout homework 0, and you get onto the homework 0 branch. And so what we're going to do is that for each homework, we're going to have a separate branch. And what you do is once you check out that branch, you work on it, you work on it. As you work on it, you add, commit, push, add, commit, push, add, commit, push, add, commit, push. And it goes to your own repository, your own private repository. And finally, we're just going to clone it and be able to get your stuff from there. And the reason we did it in this particular fashion is, here's the problem. Say you're working on homework 0, and I push into that area stuff for homework 1. There is a danger that I will clobber your hard work, and you're going to come after me with a stick and beat me. So obviously we don't want that to happen. We don't want to clobber your work. So what you do then is you work in homework 0, and when we are ready to push homework 1 out to you, we push homework 1 out to you in a completely separate branch. So we're not clobbering your homework 0 at all. And in this way, your homework 0 is safe, and everything is safe. So that's the key thing to kind of remember. You need to be working in that branch. And so this particular Git tutorial, you need to go through because it's going to show you how to branch. Unless you know how to do branching in Git, in which case You probably know it better than this tutorial will tell you how to do it. So that's the important thing. Branches are basically different versions of your same project. And you can have completely different files in them, and that's exactly what you're going to be doing. OK, so that's it. Any problems you have, please post on Piazza. You should have had some introduction to Python and Pandas today, and go ahead and do the labs. Thanks, guys.